Alrighty, here is our polar review. We're going to start, it says graph and label each point on the polar grid below, then name 3 different pairs of polar coordinates that also name the given point if theta is between -2 pi and 2 pi. So we're going to start by plotting A. So I'm going to go to -4 pi thirds. -4 pi thirds gets me here. My radius is 3, which there's 3. There is my A. Okay, so if I have 3 more pair of points that I have to have, this is a +3, so I'll have a +3, a -3, and a -3. Okay, so if I went a -4 pi thirds to get here with a positive radius, then I can also go a +2 pi thirds to get to that same spot. Then I have 2 with a negative radius, so if I have a negative radius, I actually need to end up here at 5 pi thirds. So I could go a +5 pi thirds and then a -3. Or to get to that same 5 pi thirds, I could go a -pi thirds and then -3. There are my points. Okay, so then B, it's a +17/12 and a radius of -6, so 17/12. So let's think about 12ths. Here's pi 6. Half of pi 6 is pi 12. So each little section is pi 12ths, right? This is pi, so that is 12 pi 12ths. This would be 6 pi 12ths, which means 3 pi halves is 18 pi 12ths. I only want 17 of them, so I back up a 12th. So here I am at 17 pi 12ths. My radius is -6, so I have to pass through the origin, and my point is right here. This is B. Then my other points here, I'm going to have 1 more negative and then 2 positives. So my negative actually had to get me here to 17 pi 12ths, which means then use my -6. So I need to have a negative angle. Well, remember this pi half, this would be -pi halves. So that is -6 pi 12ths. So I'm going to go 1 more, and that'll give me -7 pi 12ths. Okay, so then with the positive radius, I need to get directly here. So again, this is 6 pi 12ths. I back up 1, and that's going to give me a +5 pi 12ths. Then I can get directly here with that positive radius, so I'm going to have to have a negative angle. This is -18 pi 12ths, so I go 1 more, and I get -19 pi 12ths. All right, so then C. I'm going to go a -7 pi 4ths, so that gets me all the way around here, and then a -4 for my radius, so I am right here for C. That means I'm going to have another negative radius, and then I need the 2 positive ones. Okay, so the negative radius actually gets me to pi 4ths, and that, so I could do a +pi 4ths with a -4 radius. To get me directly here, this is going to be 5 pi 4ths, or a -3 pi 4ths. That's how you do those. All right, so then these two, says find the distance between each pair of points to the nearest hundredth. So this is a formula that I will give you. I will give you the distance formula for polar. And so that is going to be, I'll write it in this little spot here. D is equal to the square root of R1 squared plus R2 squared minus 2 times R1 times R2 times the cosine of theta 2 minus theta 1. So that is one thing that I will give you on the test. So when I substitute all that in here, that is going to give me D equals the square root of -2 squared plus 2 squared minus 2 times -2 times 2 times the cosine of 7 pi 4ths minus a negative 5 pi 12ths. And then you can just put all that in your calculator all at once. As long as you do it correctly, you are good, and you will get that D is equal to 3.86. And you're going to have to change your calculator between degrees and radians on this review, so make sure you know when to use what. I had a lot of people ask me if this was supposed to be in degrees or radians right now. So if my answer to that question was, what kind of angles do you have? And if you say you don't know, I don't know how to help you. Okay, these angles are clearly in radians, which means your calculator has to be in radians. All right, so then number 5, D is equal to square root of 4 squared plus negative 2 squared minus 2 times 4 times a negative 2 times the cosine of 5 pi 6ths minus 7 pi 12ths. Put all that in your calculator. D is equal to 5.60. All right, so now we're going to graph these equations here. So if I'm not asking you for all the other stuff like the maximum R values and the zeros and whatnot, that means these are the simple graphs, the ones that we should be able to graph accurately and quickly. It says R equals negative 3. That means the radius is negative 3, no matter what the angle is. If the angle is 0, the radius is negative 3. 1, 2, 3. If the angle is pi thirds, then the radius is negative 3. Basically, no matter what the angle is, it is negative 3. So this is just a circle, the radius of negative 3, or 3. Okay. Then we have theta equals negative 5 pi 12ths. Well, again, no matter what the angle is, theta is negative 5 pi 12ths. So it's going to be a negative angle. Remember, each little section is pi 12ths, so I'm going to go negative 1, 2, 3, 4, 5. And this is negative 5 pi 12ths, no matter what the radius is. Oh, I knew I wasn't going to get that right. And so as you pass through, try and using a straight edge like your ID would be great, but I'm not gonna. There's your line. Passes through the pole. All right, so then number 8, R equals 4 sine theta. This is going to be a circle, so I have to figure out some points on this circle. When theta is 0, the sine of 0 is 0, so there's a point right here. Then the next easy one for sine is pi 6th. So when the angle is pi 6, the sine of pi 6 is 1/2. 1/2 times 4 is 2. So there's a point right here. Since it's going to be a circle, I can do another one, then I can look at my symmetry. So then I get to pi halves. The sine of pi halves is 1. Multiply that by 4, and then I get a point right here. So my symmetry is clearly here, which means at 5 pi 6, I'm over there. And it's going to be a circle. You could plot some other points by estimating, but as long as you know it's going to be a circle and you make an attempt to actually make it look like a circle and not an egg or a football or a bloated whatever it is that I just drew, just attempt a circle and you're good. All right, so R equals 3 secant theta. Well, secant is 1 over cosine. So I can think about my cosine values and then take the reciprocal. So I'll start with 0. The cosine of 0 is 1. The reciprocal of 1 is 1 times 3 is 3. So there's a point right there. The next easy one for cosine is pi thirds. So pi thirds, the cosine of pi thirds is 1/2. Reciprocal is 2. 2 times 3 is 6. So at pi thirds, I'm at 6. Then I can go to 2 pi thirds. Well, the cosine of 2 pi thirds is negative 1/2. Reciprocal of that is negative 2 times 3 is a negative 6. So my radius is a negative 6, and I'm over here. And then I get those 3 points. That gives me a vertical line. And there are your easy graphs. Okay, so I told you can omit number 10. There's nothing wrong with it. It's not a bad question or there's no mistakes. It's just the symmetry. It takes a lot of work. It's just not necessary for us to spend time on that. All right, so then we are going to classify the curve of each polar equation. I'm going to give you a copy of that little blue sheet, half sheet, so that you can classify them. So these questions should be super easy. I'm not even going to show it up here. You should have gotten cardioid here and 8 petal rows here lemniscate, and dimpled limison. All right, so now we're going to graph some where we have to do a little bit more work to get what we need. So it says classify each curve, determine the symmetry, find the maximum R values, find the zeros, and sketch the graph of each equation. All right, so the first thing I want to do is figure out the type of curve. The type of curve here is a 3-petal rose. Then I need to find my maximum R values. So the sine of 3 theta has to be between 1 and -1. So I'm going to say if sine theta, oh, that is not an F. If sine 3 theta is equal to 1, then the absolute value of R is equal to the absolute value of 4 times 1, which is equal to the absolute value of 4, which is 4. And I say if sine 3 theta is equal to -1, then the absolute value of R is equal to the absolute value of 4 times -1, which is equal to the absolute value of -4, which is 4. So since those two are the same, I have to substitute them both back in. So I'll start with 4. So 4 is equal to 4 sine 3 theta. So 1 is equal to sine 3 theta. So the sine inverse of 1 is pi halves. So 3 theta is going to equal pi halves, but this is 3 theta, so I have to go to 6 pi, which means I'm here at pi halves, but then I got to go around again. This is 3 pi halves. This would be 5 pi halves. And then 9 pi halves. So then I divide everything by 3, and I get theta is equal to, get pi sixths, 5 pi sixths, and 3 pi halves. Then I have to substitute in the -4. So -4 is equal to 4 sine 3 theta. So -1 is equal to sine 3 theta, which means that 3 theta is equal to, so that gives me the 3 pi halves, 7 pi halves, and 11 pi halves, which means that theta is equal to 3 pi 6, which is pi halves, and then 7 pi 6, and 11 pi 6. So my maximum R values, so the absolute value of R is equal to 4 at theta equals, right, then that's going to give me pi sixths, then pi halves, 5 pi 6, oops, 7 pi 6, 3 pi halves, and 11 pi sixths. Then I need to find my zeros. I'm kind of running out of room. So let's see if I can write kind of small. Actually, I'll probably write kind of sideways so I can make it fit. So 0 is equal to 4 sine 3 theta, which means 0 is equal to sine 3 theta. So 3 theta is equal to, sine is 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay. There's lots of them. All right, so then I divide everything through by 3, so I'll just put them over here. 0 is equal to, we got 0, pi thirds, 2 pi thirds, pi, 4 pi thirds, 5 pi thirds, and 2 pi. All right, so let's think about what we got with our maximum R values. Remember, these are our maximum values, but this right here and right here are what actually go with these thetas when you're graphing, so be careful with that. So at pi 6, I have a maximum R value of 4. And then at pi halves, it's a negative 4. Okay, and then at 5 pi sixths, it's a positive 4. And then since I know it's a 3-petal rose, they should start repeating themselves. When I get to 7 pi sixths, my radius should be a negative 4. Okay, so I'm repeating now. So now I think about what kind of symmetry I have. I can answer that question right now. I do not have pole symmetry, because that would mean I'd have to rotate 180 degrees. It is not symmetric with the polar axis. It is symmetric with theta equals pi halves. So then my zeros help me know how skinny or fat to make this. So my first one after this, pi sixths, is pi thirds. So that means I can't swing out more than pi thirds, can't swing out more than 0 here. And so then this has got to be hugging 2 pi thirds and pi. Oh, I'm trying to make them more curvy and not pointy, and I'm not really good at this. It's easier on a piece of paper. There you go. That petal definitely looks better than that one. And then can't go over 4 pi thirds and can't go over 5 pi thirds. So something like that. All right, so then number 17. I'm going to start by classifying it. It classifies as a looped limison. So, got to find my maximum R values. This is just cosine theta. There's not a number there. That's fabulous when it's like that. So I've got negative 1 is less than or equal to cosine theta, which is less than or equal to 1. I can say if cosine theta is equal to 1, then the absolute value of R is equal to the absolute value of 3 plus 6 times 1, which is equal to the absolute value of 9, which is equal to 9. Then if cosine theta is equal to negative 1, then the absolute value of R is equal to the absolute value of 3 plus 6 times negative 1. And that's going to be equal to the absolute value of negative 3, which is 3. So here I don't have to do them both because I have an actual maximum, which is 9. So I'm going to use that one. And got that 9 is equal to 3 plus 6 cosine theta. So 6 equals 6 cosine theta. 1 equals cosine theta. And I only have to go from 0 to 2 pi. So cosine is 0 at, it's 1 at 0 and 2 pi. So instead of having a ton like I did on the one before, I just have 2. So the absolute value of R is equal to 9 at theta equals 0 and 2 pi. All right, so now I have to actually find my zeros. So that's going to give me 0 is equal to 3 plus 6 cosine theta. So negative 3 equals 6 cosine theta. Negative 1/2 equals cosine theta. So theta is equal to, okay, so cosine is 1/2 at pi thirds, but cosine is negative in the second and third quadrant. So I need my second and third quadrant pi thirds angle, which is 2 pi thirds and 4 pi thirds. So theta is equal to 2 pi thirds and 4 pi thirds. All right, so let's plot a few points here. Got a maximum radius of 9 at 0. And so this is 8, this is 10, so 9 is like right here. It's 0 and at 2 pi, so 0 is good enough. And then I do have some zeros. And since I know it's a looped limison, and these are 2 of the points that I have, this is going to be my line of symmetry, so this is going to be pole symmetry. Oh, I'm sorry, not pole symmetry, polar axis symmetry. Polar axis. All right, so I need a couple other points just to get a shape here at least. And since I'm dealing with cosine, after 0, my next easiest cosine is at pi thirds. So at pi thirds, the cosine of pi thirds is 1/2, right? So 1/2 times 6 is 3 plus 3 is 6. So I have a point here, and then I have a point here because there's symmetry, right? So then that 2 pi thirds would be nice, but don't have that. Well, when cosine is pi halves, or the cosine of pi halves, I'm sorry. Cosine of pi halves is 0, right? So it's 0 times 6 is 0 plus 3. So I can go out to 3 here and 3 here. So that at least gets me where I'm going to come up through pi halves, but then I can't cross 2 pi thirds, so it's going to look something like this as I go through there. And come around to make it circular, something like this. But this is a looped limison. This number right here gives me my loop, or information about my loop anyway. We could, if we substituted this back in for r, then you're going to find the theta where that is 3, and that's going to be at 0 here in 2 pi. So that's what that number is. So here's 3, which means this actually comes in, it loops around and comes back out, and it looks like that. Okay, so that's how you're going to get your loop part in there. Alrighty, and then I told you you could omit number 18. 18 is the spiral of Archimedes, and I put one on the homework, and I know it stressed a lot of you out the way you had to do it, so I don't want to, it doesn't need to be that confusing. Just want you to know that it exists. We're good. We can skip it. All right, number 19. So I need to classify this one. This is a convex limison. That means that -1 is less than or equal to the sine of theta. Still not a number there. That's great. Greater than or equal to 1. So we say if sine theta is equal to 1, then the absolute value of r is equal to the absolute value of 6 minus 1, which is the absolute value of 5, which is 5. Then if sine theta is equal to -1, the absolute value of r is equal to the absolute value of 6 plus 1, which is the absolute value of 7, which is 7. We have a clear winner here, so I put 7 is equal to 6 minus sine theta. So 1 is equal to negative sine theta. So -1 equals sine theta, which means that theta is equal to 3 pi halves. Okay, so the absolute value of r is equal to 7 at theta equals 3 pi halves. Then I need to find my zeros. So 0 is equal to 6 minus the sine theta. So that means -6 is equal to negative sine theta. So 6 is equal to sine theta, which means that theta is equal to the sine inverse of 6. So think about what that means. Can you take the sine inverse of 6? No, you cannot. That is the empty set. There are no zeros. So my graph is not going to cross through 0. It's a convex limison. Let's get our maximum r value on there and think about this. At 3 pi halves, I'm here at 7. Okay, so if you look at what a convex limison looks like, you've got your maximum r value there, then your symmetry is going to be theta equals pi halves. So let's get a couple of other points on here. Let's use, so this is sine, let's use 0. Okay, the sine of 0 is 0, and then 6 minus 0, we would be here at 6. That means that I also have 6 over here. So then we'll do pi halves. The sine of pi halves is 1. 6 minus 1 is 5. 5 is right here. And look at this number. And if you look at what a convex limicon looks like, it's kind of a wonky circle. So this is your maximum R value, but this gave you like the minimum R value, basically. Let's get a couple of other sine points on here. So other sine, easy sine ones are going to be pi sixths. So the sine of pi sixths is 1/2. So 6 minus 1/2 is 5.5, right? So 5.5 is like right there. Then I can go to pi 6 over there, 5.5. Then I can go to 11 pi 6. That's going to give me negative 1/2. So that means it's going to be 6.5. So it'd be about right there. And this would be about right there. So that gets you quite a few points to get that wonky looking circle on there. It looks something like that. All right. Okay, so now we're going to convert each pair of polar coordinates to rectangular coordinates, round to the nearest hundredth if necessary. So these are the things that I am not going to give you. I am not going to give you the fact that x equals r cosine theta and y equals r sine theta. You should know that. Okay, that is definitely something you should know. Not going to work. All right, so then I'm going to have x equals 2 times the cosine of 5 pi thirds, and y equals 2 times the sine of 5 pi thirds. Okay. So that means that x is equal to, so the cosine of pi thirds is 1/2, and then 5 pi thirds is the fourth quadrant, so that's still a positive 1/2. So I get 2 times 1/2, which is 1. And then y is equal to 2. The sine of 5 pi thirds is the square root of 3 over 2. In the fourth quadrant, it's negative, so it's going to be times negative square root of 3 over 2, which is negative square root of 3. So this gives me 1 negative square root of 3. All right, so then here x equals negative 6 times the cosine of negative 7 pi fourths. Y is equal to negative 6 times the sine of negative 7 pi fourths. All right, so negative 7 pi fourths is in the first quadrant. So basically this is the same thing as negative 7 pi fourths is equal to pi fourths. So you can just think of it that way. So this is going to give me x is equal to negative 6. The cosine of pi fourths is the square root of 2 over 2. So it's going to be negative 3 square root of 2. Then y equals negative 6 times square root of 2 over 2, which is also negative 3 square root of 2. Negative 3 square root of 2, comma, negative 3 square root of 2. Alrighty, then x equals negative 3 times the cosine of 11 pi ninths, and y equals negative 3 sine of 11 pi ninths. And once again, you got to decide what mode your calculator needs to be in. These are in radians, so your calculator needs to be in radians. And you would use a calculator here because these are not special angles that you would know. So you get 2.30 and 1.93. All right, so now we're going to go the other way. We're going to convert each pair of rectangular coordinates to polar coordinates and round to the nearest hundredth if necessary. All right, so the other part of that x equals r cosine theta, y equals r sine theta, that you would have to know is that r is equal to the square root of x squared plus y squared, and that theta is equal to the tangent inverse of y over x. And all that comes from a little right triangle in the coordinate plane if you got to draw it out to figure it out. Okay, So negative square root of 2 over 2, negative square root of 2 over 2. So r is equal to the square root of negative square root of 2 squared plus negative square root of 2 squared. So that's going to be the square root of, or when I square this I get 2 plus 2, so it's the square root of 4, which is 2. Then I've got theta is equal to the tangent inverse of negative square root of 2 over negative square root of 2, which is just going to be the tangent inverse of 1. Okay, so the tangent inverse of 1 is pi fourths. Okay, that gives me pi fourths. However, that is not the angle that I necessarily use. You have to pay attention to which quadrant you're in. This right here, negative square root of 2, negative square root of 2, this is a quadrant 3 point, which means I need my quadrant 3 pi fourths angle. It's going to be 2 and then 5 pi fourths. Oops. Hang on a second. I gotta move that over. Oh, come on. Okay. This gives me 2 and then 5 pi fourths. My instructions said, convert each pair of rectangular coordinates to polar coordinates, round to the nearest hundredth if necessary. If theta is between 0 and 2 pi, give 2 possible solutions. So that means my angle has to be positive, but my radius doesn't necessarily have to. I want to think about where this point is, right? So this point, this 2, 5 pi fourths is going to be down here. So that means if I'm going to use a negative radius, I would have to end up here so I could come back over here. That's going to give me a pi fourths. So it's going to be negative 2 pi fourths is going to be the other point. All right. R is equal to the square root of, it's a crazy square root of negative 5 halves squared plus 5 times the square root of 3 over 2 squared. It's going to give me the square root of 25 fourths plus, that denominator is going to be 4. It's going to be 25 times 3, it's going to be 75. So it's going to give me 100 over 4, which is 25. Square root of that is 5. Then theta is equal to the tangent inverse of 5 times the square root of 3 over 2 over negative 5 halves. That means that's tangent inverse of, once I do the reciprocals and or multiply by the reciprocal and reduce, it's going to be negative square root of 3. So that gives me negative pi thirds. Okay, so basically it's a pi thirds angle. This right here is in the second quadrant. Okay, so the second quadrant pi thirds angle is 2 pi thirds. It's going to be 5 and then 2 pi thirds. Then I got to think about my other point. Right? This 2 pi thirds 5, I'm up here in the second quadrant. So I would need to end up in the fourth quadrant in order to use a negative radius. So my fourth quadrant pi thirds angle is 5 pi thirds. All right, then we are going to convert this one. So r is equal to the square root of 11 squared plus negative 2 squared. So this gives me, that's going to be 121 plus 4, so that's the square root of 125, which is 5 square root of 5. Then theta is equal to the tangent inverse of negative 2 over 11. That is not it's not a special angle that we know. So when we take the tangent inverse of negative 2 divided by 11, I get negative 0.17985, blah, blah, blah. But let's figure out what I want to do here. This right here is quadrant 4, right? And this is a quadrant 4 angle, but I need it to be positive because of this statement right here. So I'm going to have 5 square root of 5 Oh, I don't know why I put a comma there. 5 square root of 5, comma, but since this is a negative angle, to get my positive angle, because I'm here in the fourth quadrant, that's where I want to be, so I have to add 360, but it's not 360 because I'm in radians. I'd have to add 2 pi, and when you add 2 pi to that, you get 6.10. Then, since I'm here, I would need to end up in the second quadrant in order to use a negative radius. So that negative 5 square root of 5, I would take this number again, and instead of adding 2 pi or 360, I would just add pi, and that will give me 2.96. There are my 2 points. All right, so we converted points. Now we're going to convert equations. Reciprocal of cosecant is sine, so this becomes r equals 7 over sine theta. And then if I multiply both sides by sine, I get r times sine theta equals 7. And since y equals r sine theta, y equals 7. All right, on 27, I need to figure out what I can do here to get it into something that I understand. And I've got r equals 6 cosine theta minus 2 sine theta. So I don't have anything I can substitute yet, but that r is equal to square root of x squared plus y squared, but I don't know that I want to put that in there because then I'd have to square it. But if I multiply everything through by r, this will give me r squared equals 6r cosine theta minus 2r sine theta. So r squared, since r is this, I also know that r squared is equal to x squared plus y squared. That means I get x squared plus y squared equals 6. Well, r cosine theta is x, minus 2 r sine theta is y. Now I have this. I'm going to have to complete my square. So I get x squared minus 6x plus something plus y squared plus 2y, because I'm moving this stuff over here, plus 2y plus something equals 0, because I would have moved both of those over to the other side. Then I have to add both of these things here. So if I'm going to add something here and here, I've got to add it here and here. So I take half of this and I square it and I get 9. Take half of this and square it and I get 1. So this is going to give me x minus 3 squared plus y plus 1 squared equals, well, since I added 9 and 1 over there, I got to do that over there, it equals 10. There we go. Now we're going to convert the other way from rectangular to polar form. So I will substitute in, I know x is r cosine theta, y is r sine theta, so this is going to be r sine, well, I'm going to go ahead and square it. So I get r squared sine squared theta over 3. So I multiply both sides by 3 and get 3r cosine theta equals r squared sine squared theta. Now I'm going to divide both sides by r, so I get 3 cosine theta equals r sine squared theta. Now keep in mind what you're trying to solve for here. We're trying to solve for r. So now I'm going to divide both sides by sine squared, so I get 3 cosine theta over sine squared theta equals r. Then I'm going to split this so I can have a cosine over sine, so this will give me 3 times the cosine theta over sine theta times 1 over sine theta equals r. That means that r equals, well, cosine over sine is cotangent, so it's 3 cotangent theta. 1 over sine is cosecant theta. And we're done. All right, number 29. So I need to square all this out here. So this, when I square this, this becomes x squared minus 4x plus 4 plus y squared plus 4y plus 4 equals 8. So if I subtract 4 from both sides, I'm going to get x squared minus 4x plus y squared plus 4y equals 0. Then I'm going to substitute in r cosine theta for x and r sine theta for y. So when I square this, this becomes r squared cosine squared theta minus 4r cosine theta plus r squared sine squared theta plus 4r sine theta equals 0. Leave my r squareds on the left, so r squared cosine squared theta plus r squared sine squared theta equals, and I'm going to move these over to the right, so I get a positive 4r cosine theta minus 4r sine theta. Now I'm going to factor things out, so I factor out the r squared over here, and I'm left with cosine squared theta plus sine squared theta equals, and then I can factor out an r here. You could even factor out a 4 if you wanted to, but at least an r, I'm going to get 4 cosine theta minus 4 sine theta. Here, this becomes 1, right? So I end up with r squared equals r times 4 cosine theta minus 4 sine theta. Divide both sides by r, so r is equal to 4 cosine theta minus 4 sine theta. And there you go. Alrighty, now we've got parametric equations. So remember, in order to do this, we have got to make a little t-chart that's literally a t-chart. And we have t, x, and y. It tells me that t is going from 0 to 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So I substitute t into here. So the square root of 0 is 0 plus 1 is 1. Then I substitute in 1. Square root of 1 is 1 plus 1 is 2. And then it's fine to use a calculator for these. It's going to give me 2.41, 2.73, 3, 3.24, 3.45, 3.65, and 3.83. Then I also take t and substitute it in here. When you do that, you get negative 4, negative 2.5, negative 1, 0.5, 2, 3.5, 5, 6.5, and 8. So then what you're plotting on your graph is just x and y. This is the only thing that actually goes on the graph. T affected the values, but they don't get graphed. So x is at, when x is 1, y is negative 4. When x is 2, y is negative 2.5. When x is 2.41, y is negative 1. Then 2.73 is, oops, went the wrong way. When it's 2.73, it's 0.5. 3 is at 2. Then 3.24 is at 3.5. Then 3.45 is at 5. 3.65 is at 6.5. 3.83 is at 8. Remember, this does not get arrows on either side that it's just going on forever. The arrows, so we connect these dots, and you got to remember in which order you plotted them in, right? No arrows on either side of this. The arrows, though, just show us the order, the direction in which the graph is going. It does not mean that it goes on forever. It's only going from 0 to 8. Okay. All right, so then number 40, same thing. We got x, oh not x, sorry. start with t to get x and y. T goes from -3 to 3, so -3, -2, -1, 0, 1, 2, 3. Substitute those in, so I substitute these t values in here. So that's going to give me -9, -6, -3, 0, 3, 6, 9. Then I substitute the t values again into y. That's going to give me 4.5, 2, 0.5, 0, 0.5, 2, and 4.5. Once again, what I'm graphing is x and y. T affected the values but does not get put on the graph. So when I'm at -9 for x, 1, 2, 3, 4, 5, 6, 7, 8. -9, I'm at 1, 2, 3, 4.5. Then -6, 1, 2, 3, 4, 5, 6. I'm at 2. Then at -3, at 0.5, 0, 0. Then at 3, I'm at 0.5, 6, I'm at 2, 9, I'm at 1, 2, 3, 4.5. I connect the dots on the curve. I think I'm going to have to go the opposite way there. Okay. And then no arrows on either side because I'm only going from -3 to 3. The arrows, since I started over here and this is the order in which I graphed them, that is the direction that the graph is moving, like so. Okay. All right. Now we're going to write each set of parametric equations in rectangular form and note any restrictions on the domain. So here we have a restriction to begin with. Like, it doesn't tell us that as far as the t's are concerned. Sometimes it will. But this one does tell me that I have the square root of 5t, which means this right here has to be greater than 0. So since 5t has to be greater than or equal to 0, then t has to be greater than or equal to 0. Right? And now I'm going to have to solve one of these two for t. It doesn't matter which one, but I would say let's go ahead and get rid of the square root. So if I square both sides, I'm going to get that x squared is equal to 5t. So t is equal to x squared over 5. So then I'm going to substitute that in here for t. And that's going to give me y equals negative, then 5 times x squared over 5 over 3. Well, those 5's cancel out, so y is equal to negative x squared over 3. But then I have to have a restriction here, right? So since t has to be greater than or equal to 0, I take this 0, substitute it in here, and I get that x equals 0, so that means that x has to be greater than or equal to 0. And there you go. I wrote this correction on the board, but I think I forgot to tell most classes. Oh, I think it got erased before the second half of the day anyway. Yes, this is supposed to be a fraction bar, and this should have been -1. I don't know what happened to those when I move things around. Things just disappear. Here, I do not have any restrictions on the domain to begin with, so we'll just have to see if we do in the end. In order to decide which one to solve for, I think that I would definitely solve for t and the y here. So this means I'm going to get y plus 1 equals t over 2. So that means that t is equal to 2 times y plus 1. And I can just leave it like that, or you could have multiplied it out. It doesn't matter. Then I'm going to take this and substitute it in. And when I do that, I'm going to get that x is equal to 2 times y plus 1 squared plus 3. So x is equal to 4 times y plus 1 squared plus 3. Well, I need to get y by itself, so I'm going to subtract 3 from both sides. X minus 3 equals 4 times y plus 1 squared. Now I'm going to divide by 4, which is the same as multiplying by 1/4. So 1/4 times x minus 3 is equal to y plus 1 squared. So then I'm going to take the square root of both sides, and I'm going to get plus or minus the square root of 1/4 times x minus 3 equals y plus 1. So y is equal to, now let's think about what's happening here. This is the same thing as even if I don't distribute, this would be x minus 3 over 4, right? And so I'm going to kind of rewrite this as a separate, well, if you could rewrite it as separate fractions, like the square root of x minus 3 over the square root of 4. You cannot have a fraction inside of a square root, so I can take the square root of this 1/4, and the square root of 1/4 is 1/2. So this really is plus or minus the square root of x minus 3 over 2. Or I could have put the 1/2 out front, either way. And then I have to subtract this 1 over here, and this is what I've got. But I do have a domain restriction, because I didn't up here, but here I do, because I know that whatever's underneath the square root has to be greater than or equal to 0. So that means x has to be greater than or equal to 3. There's the domain restriction that goes with it. All right, 43. I need to convert these to rectangular, which means I got to have something to be able to solve for here. And I need to get cosine and sine by themselves so that I can use some of the identities that I have. So this is going to give me x over 2 equals cosine theta, and y over 7 equals sine theta. Well, I know that cosine squared theta plus sine squared theta equals 1. That means that x over 2 squared plus y over 7 squared has to equal 1. So x squared over 4 plus y squared over 49 equals 1. And I'm done. If they're both squared, you don't solve for either one of them. All right, so now let's look at 44. I've got, to get cosine theta by itself, it's going to be x minus 3 equals cosine theta, and y over 4 equals sine theta. So once again, I have cosine and sine, so I can do cosine squared theta plus sine squared theta equals 1. X minus 3 squared plus y over 4 squared equals 1. Oh, shoot, this should have been x plus 3. Dang it, because it's minus. All right, so then I don't have to square this one out, but I do need to clean that up. So I get x plus 3 squared plus y squared over 16 equals 1. And I'm done. Alrighty. Now, a soccer goalie makes a save, then drop kicks the ball down the field. The ball travels at an angle of elevation of 40 degrees at an initial velocity of 30 feet per second from a height of 1 feet above the ground. What was the maximum height of the ball? All right, so to find the maximum height of the ball, I'm going to have to find the maximum time, and I'm going to have to use my y equation, right? So this is going to be y equals t times the initial velocity, which is 30, times the sine of the angle, which is 40, minus 1/2 of the gravity constant. So your gravity constant here is going to be, since it's feet per second, is 32. Half of 32 is 16 times t squared plus the initial height, which is 1.5. All right, so in order to find the maximum height, I have to know what time it hits the maximum height. So that is where you're going to get your negative b over 2a. So t is equal to, this is b, so negative 30 times the sine of 40 over 2 times your a, which is a negative 16. Okay, I got interrupted, so I'm not sure what exactly what the last thing is that I said, but once you set that up, negative b over 2a, to find the time when it's at the maximum, put that in your calculator, and you should get 0.602, blah, 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 and you need to store that. Then you are going to take that number, and you're going to substitute it in here and over here, so that you can actually find the maximum height. And when you do that, y should be equal to 7.310 feet. Now, that 6 number should be stored in your calculator, and it should still be there. It says, what was the horizontal distance of the projectile at its maximum height? So I need my x equation, okay? And I will give you the setup for these. That's going to give me x is equal to that time that I have stored, right? The time that I have stored times 30, which is my initial velocity, times the cosine of 40. Right, so again, I take this, I'm going to substitute it in right there, what's stored in my calculator, and you should get that x is equal to 13.849 feet. All right, so we have a projectile. Is fired from 22 meters above ground. Projectile has traveled with initial velocity of 55, so we're at meters per second now, which means that's 9.8 is your gravitational constant. So it says find the difference in the height of the projectile after 2 and 4 seconds. So I need two different equations. My y1 is going to be 2 times 55 times the sine of 60 minus half of that 9.8 is 4.9 times 2 squared plus 22. And then my y2 is going to be equal to 4 times 55 times the sine of 60 minus 4.9 times 4 squared plus 22. So I substitute them in. I put those in my calculator. Y1 is going to give me 97.663, blah, blah, blah. Store that in your calculator. Y2 is going to give me 134.1255, blah, blah, blah. Store that in your calculator. So what I really want in the end is y sub 2 minus y sub 1, and the difference is 36.463 meters. So then it says find the total horizontal distance the ball traveled at the time it reaches the ground. So that means I need the zeros. This is where the quadratic formula comes in. So my just generic formula here, y is equal to t times 55 times the sine of 60 minus 4.9 t squared plus 22, and I set that equal to 0. Then I do x equals, it's really t equals negative b, so negative 55 times the sine of 60 plus or minus the square root of 55 times the sine of 60 squared minus 4 times a times c all over 2 times a, which is negative 4.9. So if you type all that in your calculator and you actually use the fraction button, all that stuff, you're going to have to do it twice, but if you do plus the first time and then you just arrow back, you can just change the minus sign. You get that t is equal to negative 0.442 and 10.162. This one is not what we want. This is when it would actually hit the ground here. And so that needs to be stored in your calculator, whatever it said before I rounded it. Then you're going to take that and substitute it into the t's up here so that you can find, oh, not the t's up there. That doesn't make any sense. That is not where you're substituting it in. We would need the x equation because we don't want the horizontal distance, the vertical distance, we want the horizontal distance. So we have x equals t times 55 times the cosine of 60. And then you're going to take this and substitute it in there. That's what I meant. And you get 279.46 0.69 meters. Okay. So just to recap, I'm going to give you the little blue sheet of paper that has the classic polar curves on it so that you can organize them. I will give you the polar distance formula. I will also give you the naked forms of these, but I'm not giving the r cosine theta, r sine theta, square root of x squared plus y squared. That stuff you should know. Okay, so come ready so that you can do well on this.